All right, welcome. Today, we're going to dive deep into a design that's really at the peak of enterprise cloud networking. We're talking about building a true private global backbone on AWS. This isn't just about connecting a couple of VPCs. Nope. This is the principal architect level blueprint for creating your own worldwide network. Let's get right into it. So, you might be asking, why is this so important for businesses today? Well, this slide really tells the whole story. For years, if you wanted global connectivity, you were locked into these rigid, super expensive MPLS circuits. We're talking $50,000 a month, maybe more, for just one link. What AWS lets us do is completely flip that model on its head. We're moving from a costly, static thing you just pay for to an agile, private, on-demand global network that you, the architect, are in complete control of. And look, the need for this is more urgent than it's ever been. Businesses today demand real cross-continent disaster recovery. They have to give their users in Tokyo the exact same snappy, low-latency experience as their users in Toronto. Your core business systems, they're not sitting in one data center anymore. They're spread out across multiple AWS regions. And you need one single, unified way to plug all of your branch offices into this new cloud-native core. These are the business drivers behind the architecture we're about to build. Okay, but before we start clicking buttons and connecting services, we have to stop and understand the single most important rule in all of AWS global networking. If you get this one concept, the rest of the design just clicks into place. This is it. This is the critical piece you have to grasp. A direct connect is, by its very nature, a regional service. What does that mean? It means that physical connection you have in Virginia, it terminates right there in the US East 1 region. You absolutely cannot use that same physical wire to directly talk to your resources over in, say, Tokyo. It's a fundamental architectural constraint. It's a hard boundary, and it dictates every single design decision we're about to make.
So if Direct Connect is stuck in its region, how in the world do we get across continents? Well, we have to follow this exact path. This is the official AWS prescribed pattern. Your traffic starts on-prem, it goes through that regional Direct Connect, and the first thing it hits is something called a Direct Connect gateway. From there, it gets handed off to a transit gateway in region A, which then, and only then, can it peer across the AWS backbone to the transit gateway in region B. That's our roadmap.
So to build out this path, we need to get familiar with our toolkit. It really comes down to 3 core services that all work together to make this global network a reality. Let's quickly break down what each one does. First up, Direct Connect, or DX. The easiest way to think about this is as your physical front door into AWS. It's your private, dedicated fiber line that runs from your data center or your colocation facility straight into a specific AWS region. It's the on-ramp and nothing more. Next, we have the Direct Connect Gateway, or DXW. Now this is the magic component that solves our regional problem. The DXW is a truly global resource. It doesn't live in any single region. Its entire job is to be a global router. It takes that regional on-ramp from your Direct Connect and makes it available to any other AWS region you want to connect to. This is the key. And finally, the Transit Gateway, or TGW. So if the DXGW is our global connector, the TGW is our regional hub. Inside each region, inside Virginia, inside Tokyo, the TGW is the central traffic cop. It connects all your VPCs, your VPN connections, and that feed from the DXGW all into one clean, manageable hub-and-spoke setup. Okay, we know the role, we have our components. Now, let's actually assemble the blueprint. Let's walk through the global architecture, piece by piece. Conceptually, I find it helps to think of this as a 4-layer model. Your traffic is born on your on-premises network. It gets onto the AWS network using that local Direct Connect on-ramp. Then it hits the DX gateway, which handles the global transit piece. And finally, it directs it to the correct regional hub, which is our transit gateway. That's the logical path every single packet is going to take. So let's build this out. First leg, we provision a Direct Connect circuit, let's say somewhere in North America. We then attach that circuit to a global Direct Connect gateway, and then we associate that DXGW with our transit gateway running in the Virginia, US East 1 region. Boom! Just like that, our data center now has private, direct access to every VPC attached to that TGW in Virginia. And here it is. This is the move that takes us global. We now create a transit gateway peering connection between our TGW in Virginia and our TGW in Tokyo. This right here is where you see the immense power of the AWS global network. This peering connection is a massive encrypted link that runs entirely on Amazon's own private fiber. And the crucial part? That traffic never, ever touches the public internet. Now, this basic architecture is incredibly flexible. It's not one size fits all. For a medium-sized company, a single DXGW is often perfect. It's simple, it's lower cost. A larger enterprise, though, is probably going to deploy a second DXGW on another continent for full geographic redundancy and route isolation. And for those huge multinational corporations, this whole design becomes their new cloud MPLS, a single unified backbone where they can route and inspect all of their global traffic from one place. So we've built the network, it's all connected, but what does this design really get us? Let's talk about the payoff, because the enterprise-grade control that this architecture unlocks is a total game changer. The biggest payoff here is control. This isn't some static black box connection. The whole thing is built on BGP, the Border Gateway Protocol. That's the routing protocol that runs the internet. This gives your network engineers the kind of precise carrier-grade control they're used to. You can use BGP attributes to set route priorities, making your US link the primary and the APAC link the backup. You can fully automate failover paths, not just between direct connects, but even to a backup VPN. You can even do advanced things like use AS path prepending to engineer how traffic comes back to you. It's a real network. So what's the end result of all this? You've built a single, unified, geo-redundant global backbone. It gives you private, any-to-any connectivity between your data centers and any AWS region you operate in, all with predictable low latency and, most importantly, absolute control over your own traffic. You're not just renting a circuit anymore. You are operating your own global network. And here it is, the whole thing put together. This is the blueprint. You can see how the on-prem sites use redundant direct connects to get to our global DX gateways. Those gateways then feed into our regional transit gateways, which are all interconnected with TGW peering. This is the architecture for a resilient, principal-level global network, and you now understand exactly how every single piece fits into that big picture. So there you have it, the blueprint for a world-class, enterprise-grade global network on AWS. But designing the transport layer, that's really just step one, and it raises the next really critical question. Your backbone is built, the traffic is flowing, but is it secure? We'll have to explore that one next time.